Hi everybody, this is Matt Morgan. In this lesson we're going to talk about resonance structures from Wiley's section 9-5. We'll talk about some weaknesses of the Lewis model, why we need to draw resonance structures. We'll draw the structure for the nitrate anion NO3-, and we'll work Wiley problem 9-44. The Lewis model does a great job of showing how molecules bond. That's a very complex concept. There's a lot more to it than just atomic symbols, lines, and dots. But any model becomes less accurate as it becomes more simple. So resonance is a weak area of Lewis structures. It depicts single, double, and triple bonds very well. But some substances don't bond so simply. They kind of sort of bond in between a single and a double. So let's look at the nitrate anion, NO3-. If we draw its structure, we'll find that one of its bonds is a double bond. Let's draw its structure and see. NO3- are valence electrons, 5 for nitrogen, 3 times 6 valence electrons for the 3 oxygens. We add 1 because it has a negative charge. That gives us 24 valence electrons. After calculating valence electrons, we draw the structure. Nitrogen in the middle, surrounded by 3 oxygens. There's our 3 bonds. So far we have 6 bonding electrons. We have to find homes for 18 more and hopefully give every atom an octet. We put our brackets in a charge because it's a polyatomic ion. There's our lone pairs. We have placed all 24 electrons, and nitrogen still needs an octet. So we have to form a double bond. But where? That's a question. Do we put it on the top oxygen, lower left, or lower right? Scientists can measure bond lengths, and they've figured out that a single bond is longer than a double bond. The double bond is shorter than a single bond. They've measured the bond lengths for nitrate, and they found that all the bonds are the same length, and that bond length is somewhere in between a double and a single bond. The Lewis structure cannot show that very accurately. It cannot show that well. So what do they do for something that has a bond length about a bond and a third? What they do, if you are drawing a Lewis structure and you have to make one double bond from equivalent choices, you draw all 3 structures, and it's assumed that the actual structure is an average of those 3 what we call resonance structures. We draw all 3 molecules with the brackets with arrows, double-headed arrows, in between. That tells us that this structure is a hybrid. It's an overall combination of all these 3 structures. In terms of drawing Lewis models, it's kind of a pain because you've got to draw 3 and not just 1. Other species requiring resonance structures, and there are many, many. Here are just 2 more examples. The nitrite, NO2, ozone, O3. These Lewis structures require resonance. So when you have a choice of where to draw a double bond, 2 or more equivalent choices, you must include all possible structures. Let's look at a Wiley homework problem that deals with drawing resonance structures. The problem says, choose the correct resonance structures or Lewis structure if no resonance structures exist for CO3-2-. That's the carbonate anion. So let's start by drawing its Lewis structure. CO3, 2 minus, carbon has 4 valence electrons, 3 oxygens, each having 6. We add 2 because the polyatomic ion has a -2 charge. That gives us 24 valence electrons. There's our carbon, surrounded by the oxygens. If this looks similar to the nitrate, I hope you see the similarities. Definite patterns here. There's our bonds, 6 bonding electrons. We'll draw our brackets in the -2 charge this time. Fill in our non-bonding electrons. And just like nitrate, we have used all of our valence electrons. Carbon this time does not have an octet. We need to draw one double bond, but we have 3 choices. So for our resonance rules, we have to draw 3 equivalent structures, showing the double bond on each of the carbon-oxygen positions. We have to draw 3 resonance structures. So for the Wiley homework problem, we select one choice. Only one answer shows 3 resonance structures. The other 2 have problems in addition to not showing all 3. On your own, at another time, see if you can find the errors with the other answers. But it turns out that the answer we select for this homework problem is the one that shows 3 resonance structures. Now this homework problem also has a second part. What are the implications for bonds where resonance exists? So we have to select one. The first choice, molecules with resonance structures are unstable and cannot exist without forming other bonds. That's not a true statement. The actual bond is stronger than a triple bond. That's not true either. We've seen that our resonance structures, the bonds are somewhere in between a double and a single bond. Third choice, each molecule forms as one of the resonance structures. There are therefore multiple molecules. That's incorrect as well. There is only a single molecule. And our fourth choice, the actual bond can be viewed as an average of the resonance structures. That statement is correct, and that is the choice we will mark. So we talked about weaknesses of the Lewis model, and we practiced drawing resonance structures. We worked a Wiley homework problem. Keep looking at those problems. Keep working them out. If you have questions as you work the problems, contact one of your course mentors. Corey and I are very willing to answer any chemistry questions you might have. Here is our information. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.